to get an idea of how where the state of water quality, as well as what habitats are maybe changing in the area. So, want to invite our first presenter up, Jon Perry.
Okay, good morning. My name is Jon Perry. I'm with Environmental Science and Associates, was ESA. I'm a contractor with the Sarasota Bay Estuary Program and Sarasota County, among other municipalities in the area. I'm going to be talking about water quality and the little Sarasota Bay Watershed Management Plan, which is coming to a completion right now that we're doing for Sarasota County. Little Sarasota Bay has had a lot of management actions that have occurred over the years that affect it. Back in '95, the Sarasota Bay Estuary Program began and created the CCMP. Sarasota County is under the NPDES permit, so they're looking at managing water quality as well as flooding. The first swim plan from Swift Mud from 1997 was done. We've just recently completed the update of that too in 2025. Numeric nutrient criteria for certain things that came out. The first little Sarasota Bay Watershed Management Plan the county had completed was done in 2012, and that accounted for water quality as well as flooding. This year, the Water Quality Protection Plan that Sarasota Bay was working on was completed, and we're currently finishing an update of the little Sarasota Bay Watershed Management Plan. What's common about most of these things is that they're really primarily focused on total nitrogen, phosphorus, the nutrients that are being delivered to the bays themselves, and the responses according to chlorophyll and seagrasses and how those things have changed over time. So I'm going to primarily talk about water quality. I believe Tara is going to be talking about seagrasses, and Dr. Emily Hall is going to be talking about other water quality parameters as part of the moat monitoring program. So in Sarasota, Sarasota County itself has a water quality level of service that they strive to in order to achieve in all these water bodies. The standards are there, 10.4 and 0.6. Annual geometric means that they look at. The Sarasota Bay Estuary Program, they devise their own targets that they're trying to achieve within the bay for chlorophyll and nitrogen. And DEP, which is the regulatory standard for the state, has their standards as well. It turns out the county and the DEP have the same standard. The Sarasota Bay Estuary Program, as part of their recent report card development, they created their own standard. They looked at the mean of the period between 2006 and 2012, where the other criteria were set many years ago, actually, back in 2010, I believe. So just real quick, the water quality in the bay, these are what's called, and for this slide, chlorophyll, we're looking at annual arithmetic means. So it's the average for the entire year. Right, so this is the annual geometric means for all the years. This is set up in 3 different time frames based on what we had done for the Water Quality Protection Plan. There's the quote-unquote good old days when everything was pretty much well below the standards except for a few excursions. There's an area in the red where there's many excursions over the limits for the criteria for chlorophyll in this case. And then the end is since 2020, where things have gotten better and everything's a lot less than it was before then. The big peak in the second to the last peak is the 2024 year, when we had 3 hurricanes that dumped a lot of water on us, created a lot of runoff, and probably affected the bay quite a bit. And then the 2025, the last peak, is after the pass opened, and you can see how well it dropped after that. But it's also in line with what it was before the pass was open. So, we still have a little more work to see what the effect on the pass, not the bay itself, we're going to see. This is just another way of looking at the chlorophyll. We're looking at annual geometric means, which gets rid of the highs and the lows out of the mean calculation and allows it to be a little more, quote unquote, cleaned up as a trend. And the Sarasota Bay limit is about 4.9, I think it was. So we're right around there in these current periods. Total nitrogen is another one that drives chlorophyll itself. Again, the same 3 time frames. You got a good period, a badder period, and a better period. It's interesting. You can see a pretty much negative trend going on since 2018 that we've noticed. So we find that to be very important. and determining how much chlorophyll we're going to be growing within the bay, which blocks out seagrass, and we have that whole issue with light blockage. And finally, total phosphorus. We had a decreasing trend all through up to 2012, where that quote-unquote bad period was. We continue to come back down. But what's interesting is in the last 2 years, 24 and 25, we have a doubling of the amount of total phosphorus that's available within the water column. We haven't really looked into what's been causing that, but we'll get to that soon. So that's my quick 5 minutes on water quality. Now I want to talk about the Little Sarasota Bay Watershed Management Plan. The speakers this morning touched on some of these subjects. We did this for Sarasota County. They hired our team that you can see here to conduct the watershed management plan. We looked at doing a flood assessment. So we looked at places where we were flooded, whether it be structures or roads, and we tried to devise projects for that. Surface water resource assessment. We looked at where the highest quote-unquote hotspots, which are these higher red areas in the map, and try to see if we can come up with projects to reduce the load entering Little Sarasota Bay from the watershed. Natural system BMPs, so we're trying to bring back some of the natural sinuosity in the water and the canals and creeks within the watershed to reduce, slow down the water and increase treatment. We looked at how we could prioritize septic systems in order to take them offline and reduce load. And we looked at hydrologic models. This morning when we were talking about the models that are being developed as part of the Midnight Pass, we're actually using that same model in part of the watershed management plan to monitor circulation, but we're also finishing up the water quality portion of the model that we expect to have it in the report by the end of this month. So that should be coming out real soon. So, and we had a public outreach section where we actually went out into we engaged the community, and we met with members from those neighborhoods. We had that many organizations that we touched. So we got the word out that we're actually conducting the project so that there would be some community buy-in as well. And out of that plan, we got 10 water quantity projects to help alleviate flooding of structures and roads. We got 8 water quality alternatives where we're going to reduce the total amount of nitrogen hitting the watershed, Little Sarasota Bay, by almost 9,000 pounds per year. We got 5 stream restoration projects, which could additionally reduce another 1,700 pounds per year. And finally, if we prioritized and completed the septic to sewer areas that we looked at, we reduced another 2,500 pounds per year to reach Little Sarasota Bay. Again, this was all done by Sarasota County. They're the funders for the program. There's a website on the county's webpage where you can actually go in and look at all the materials, all the presentations that went involved in developing the watershed management plan. The link is at the bottom, but I know if you just go to just search on Sarasota County, Little Sarasota Bay Watershed Management Plan, it'll take it right there. It's a direct link. Google first hit. So that's how I found it. And that's all I got.
Thank you, John. All right, next is Dr. Emily Hall from it.
Hi, I'm Emily Hall. For those of you I haven't met, I'm a senior scientist and program manager at Moat Marine Laboratory, where I manage the chemical and physical ecology program as well as the ocean acidification program there. We have been collecting and analyzing water samples from Sarasota Bay within the current monitoring program since 1998, under the direction of Dr. Kelly Dixon and Ernie Estevez. They're both retired now. There were earlier, sometimes fragmented efforts throughout the Bay. You can see in reports by Ernie and Kelly from 1989, 1993, they helped develop the structure of the monitoring program for evaluating water quality. And we are funded by Sarasota County to do this work. We follow FDEP SOPs for field sampling unless otherwise suggested by the county. We do this once a month, and we have 3 crews out in the same day to be able to capture the samples all within the same time period. We are a NELAC lab, so we also analyze all of the samples as well. We started collecting samples for Karenia brevis cell counts in 2016. The collection of those samples is funded by the county, but the analysis of those samples is funded by Florida Fish and Wildlife. So it's been patchy sometimes. And so we're obviously talking about Little Sarasota Bay, so you can see the map and you can see the segments that I'm talking about. I'll mention 14.1 through 14.5. These are the constant monitoring, the monthly monitoring that we do, and where Midnight Pass falls right in the middle of that. So here are some tables. I apologize, they got cut off on the bottom, but here's tables of all the parameters that we collect in situ using meters and other field observations, as well as laboratory analyses. For the next few slides, I do want to show, Jon evaluated some of the data, looking at those kind of different time periods that they've made the plans with, but I just wanted to look at the data pre and post the opening of Midnight Pass. There are plenty of other ways to look at this data that we haven't had time to dive into yet, but we will be moving forward. But there are some things to keep in mind when looking at the data and the statistics the way I'm doing it here. There are currently only 19 months of post-event data, so we would need probably about 3 to 5 more years of monitoring to really see what the trends are doing based on the opening of the pass. It's clear that the opening of the pass has dampened some of the baseline levels, but has not eliminated pulses that we've seen in the past. So for example, you'll see a chlorophyll A spike in September of 2025 after the pass opened. Oh boy. The hurricane-driven nutrient pulses and freshwater influx from the storms themselves may account for some of the immediate post-event changes, which could differ from long-term steady state under open pass conditions. And it's important to acknowledge that we've been in a drought for roughly 9 months since September of 2025. And so you won't be able to see the details in these, but each of these 4 figures here represents a parameter, and each line within the figure represents the different segments, so 14.1 to 14.5. And these 4 figures represent parameters that showed no significant difference, statistically no significant difference between those two time points. So it's turbidity, ammonia, total phosphorus, and water clarity by Secchi. But some things to point out, as you can see in turbidity, there were spikes after. So maybe not significant overall trends, but we are seeing some increases in turbidity, clearly. Ammonia, nothing, but it's primarily controlled by local biological processes rather than simple dilution by tidal flushing. So it kind of makes sense that we wouldn't see much difference with that. We do see, Jon talked about increases in total phosphorus, and we do see spikes in total phosphorus. It just didn't come out as significant in the test that I chose to run. And interesting, water clarity, that's by Secchi disk, so it tends to be a little bit all over the place. These 4 figures here show data that showed some significance at some stations, but not overall. So chlorophyll A and BOD, which kind of follow each other, we still see the September-October bloom spikes. And then I mentioned that spike in September of 2025. So the pass hasn't eliminated any kind of seasonal bloom there. Keep in mind, some of this old data is taking into account when we get Cranea brevis blooms, and we haven't had a major bloom come through. So that's another reason why I say we need to have longer data sets to really follow this. And nitrite, interestingly, we do see a post-storm increase, not decrease in nitrite. So I was interested when the commissioner mentioned that we've seen in these pictures of the water chemistry changes, what those were looking at, or how we were evaluating it for that. And then these 4 parameters were the ones where we saw the most significant changes. Light attenuation and true color, we do expect to see those get better as we have more of that Gulf water coming in those areas. And then interesting, phosphate. So I mentioned that total phosphorus increased, though not statistically. Okay, I'm going to be a jerk and take a few more seconds. Okay, not significantly. So tidal flushing could be diluting the so we saw a decrease in phosphate, but it's just the biologically available, form, not the total phosphorus, and so that total phosphorus is going up. So that's that organic bound phosphorus or particulate phosphorus that could have been brought up into the water, with the movement of all the sediment. So that's quite interesting too. And then we did see a decrease in TKM. Lastly, just general water quality parameters. We see salinity increase and conductivity, but no very significant changes. 1 point in dissolved oxygen, but again, we need to look further. So we can scrutinize this data more carefully. I don't have time. Obviously, I'm over time. The main points are that some parameters changed, some didn't. We need more years worth of data to really evaluate the differences that the opening may have had on the chemistry, especially if a Cranea brevis bloom comes through in the next few years. But we have plenty of data to look at, and we will continue to scrutinize it. So talk to me if you guys have any more questions on that. Sorry for going over.
All right, next we'll have John Ryan.
I'm bound to push the wrong button. Hi, I'm Jon Ryan. I'm with Sarasota Bay Watch, a nonprofit here locally, and we're an organization that hosts events for people to volunteer. And so some of the things we do are clam restoration, which is led by Ernesto Lessa de la Vega right here, and marine debris cleanups. We're having a dive cleanup downtown on the 14th. And one of our other projects is Jim Neville Marine Preserve, which is this. So you've seen these pictures and a lot of other people's slides. Am I loud enough? And so this over here is, let me just, I better look at my notes or I'll talk about everything under the sun. So what we're doing out there at Jim Neville is there was some dredge spoil dumped there back in the 60s. And so we're going onto that elevated area, which has become 100% invasive species, and we're replacing it with native species using mostly young people. Youth leadership is one of our big things. It's one of our central things. So Jim Neville Preserve is county owned. It's 114 acres. It used to be 100% mangrove island. And, but back in the 60s, which you can see in this picture, in 69, they dumped 2 piles of dirt from the Intercoastal Dredge Project. So one of them is kind of this V-shaped thing and the other blob down there. In 2022, this is before Hurricane Ian, very dense forest. You could hardly walk through it. 100% Australian pine with Brazilian pepper and carrot wood. That's all that was there. And so when you get to the entrance, you couldn't walk anywhere except right by the mangroves. And that's when we started our project. So let me back up a little bit and make sure I get this history right. Old guy needs glasses. So in the 60s, the dredge of the Intercoastal dumped that stuff. There was a dense invasive forest. So in 1980, this was owned by the Palmer family, like Mrs. Potter Palmer, her descendants, and a trust. In 1980, it was sold to Sarasota County for $10. And in the deed, it says it must remain a pristine and undeveloped place. Around that time, it was named after a former county commissioner, Jim Neville, who was a natural kind of guy. And 2010, we started doing cleanups with Pineview School, and eventually it was so clean there was nothing left to pick up. So we asked Sarasota County if we could start doing this invasive removal and planting, and so we started that in 2022. So the project's had some bumps in the road, and if you look at this 2026 picture, that's after all the hurricanes. Ian had an effect, but not big like Helene and Milton. So about 12 acres, that whole gray perimeter, not the one big blob, but the whole perimeter, that's about 12 acres of Australian pines that were knocked down, and almost everything in that below 4 feet elevation was killed. So that was a big change. We had a pretty good trail all the way around in this top piece. We had a lot of pollinator plants and that kind of blob in the corner. That's really where all our restoration is. And it was a rough go, and it still is. We're still working on it. Then we had what Emily says, 9 months of drought. That's not awesome for a planting project where no fresh water is there. We have to bring it if it's a drought. So those were hurdles, but we love doing. And so we have hundreds of people have been out there, donated thousands of hours, lots of kids, and being around. People complain about teenagers, but the ones we see are awesome people who we are glad to know and happy to talk to. We get mother-daughters like this group here, fathers and daughters and sons, and it's dirty. We paddle out there in kayaks and walk through the mud, and we dig holes, and we move branches and logs. Believe it or not, people love it. They love to be part of it, and they're very happy. It's very common for us to hear, "Thank you for doing this. Thank you for letting me be part of it." And it's our aspiration that some of these young kids, when they come back in 20 years with their kids, and there's a big forest of native plants there, that they'll be the environmental leaders of the future. So that is a very key part. Every day there's habitat there is a good day for wildlife, but every day that a kid gets the bug to want to do something is a great day. So that's what we want to do. It's also totally fun. We have lunch, we enjoy each other's company. It's a great time. We planted lots of flowers. We planted, I think, 77 species of native plants in that one area. We were doing a lot better before the hurricanes. You know, a lot of these things don't like being underwater in a washing machine of saltwater ocean. Some do. Some do. They're perfectly fine with that, and they grew just fine. We have raccoons that come up. They practically walk right up to us. These little babies, they don't know that they should be afraid of us. So it's a great place to be. We love doing it. We also have a young woman, this woman right here. I've got to say her name, Sophia Hackman, amazing human being. She started a bird study to compare the restored versus unrestored areas. I'll be done pretty soon. And she created this youth leadership program. They got their own t-shirts. She made that with AI. Every one of these young kids is an amazing person and super interesting to be around. They love birding with a passion you can't believe. It's fun to hear them talk about it. They love birds and birding. Sanjay right there, 12 years old. Look at that camera he's got. He made his mom drive down a dirt road in South Dakota last summer to go see some bird that lived down there. Great kid, great mom. So this is sort of some of the weird stuff that we have to deal with. So when all the trees fell down, what used to be a trail became a pile of logs. That's kind of a big deal. So we have brush piles, which we treat them like habitats. So we build kind of a crossword, that pattern up there in the top right. So we build it so it can be a habitat. And then we put the brush on top because we've got lots of debris, lots of logs. We pile up the logs in log piles like there at the center. We plant vines to grow over them just so it looks better. And we try to put a lot of stuff in low elevations. So like here on the bottom left, that's right next to the mangroves. So water gets in there, high tide, and helps it to rot and decompose and go away. Believe it or not, last weekend we had people out there piling brush on those things, and they loved it. It was a really good time. We enjoyed each other. If you look there in the bottom right, that's what happens when Australian pines tip over. See that guy standing in front? Those are roots. That's a tipped over Australian pine. That's the biggest one, like 20 feet tall. I think that's all I have to say. If I didn't look at my notes, so I probably missed some stuff. But thanks for your time.
All right. Please welcome Tara Harter.
Perfect. Good afternoon or good morning. I'm Tara Harter. I'm a staff environmental scientist with the Surface Water Improvement and Management section at the Southwest Florida Water Management District. Today I'll be talking to you about the seagrass trends in Sarasota Bay, but also specifically in Little Sarasota Bay. As canaries of the estuaries, the seagrass are very sensitive to water quality degradation, and the Water Management District has been mapping seagrass every 2 years from Tampa Bay to Charlotte Harbor since 1988. So right after the pass got closed originally. Let's jump right in. Sarasota Bay, the entire watershed, experienced a significant loss following the red tide events. So in 2018, we saw a significant loss in the seagrass meadows. This loss continued into 2022. So as you can see up here on the map, we've got this significant loss here. But in 2024, we saw a really large rebound, specifically north of Long Bar Point up in this area. Sarasota Bay proper is what we refer to that larger bay segment. It increased by 1,800 acres. So that was a huge gain. In this graphic here, with this darker signature is our continuous grass beds. Those are denser grass beds. We love to see that. And the lighter green are our patchier grass beds. So if we look at this trend, we can see this is the total seagrass coverage, and then we have our continuous seagrass coverage, those denser beds, and then our patchy seagrass coverage. You can see right here that we have continuous grass beds increasing. That's mainly driven by that gain that was seen in Sarasota Bay proper. But we do like to see that the continuous grass beds are pretty stable and increasing over time. Unlike the rest of Sarasota Bay, though, Little Sarasota Bay actually experienced loss of seagrass in 2016. Likely due to nutrient increases, but if we look down here at this graphic, we can start to see that the grass from 2016 all the way to 2018 had started to decrease, so before those red tide events. What's interesting here, though, is that we actually had an increase in the continuous grass beds in 2020, which we love to see, and it's actually been pretty stable since then. It's been relatively little change in the Little Sarasota Bay since 2020. Midnight Pass, as we're all familiar, opened in 2024. And I would like to note that our seagrass maps were actually completed the imagery was collected prior to those hurricanes. So we do have a good pulse before the hurricanes came through, and we're excited that we're working on our 2026 seagrass maps currently. As you can see down here in this graphic, this is where the seagrasses were before the pass opened. So you can see that there's some continuous grass there and some patchy grass here. But as I said, we're working on those 2026 seagrass maps. And this is a preliminary image from our 2026 seagrass maps. This hasn't been post-processed. It'll definitely be a clearer image once they get done with it. But what I'd like to show you guys is that we do have maybe possibly a signature of some haliduli up in this area. And once this image gets post-processed, we'll be able to see that a bit better. The biggest concern in this area right now is the sediment moving around and possibly burial. What's also important to note is this aerial imagery that we collect. If it's under 10% seagrass coverage, it's very hard to see from that high in the air. So it might take a little bit longer to see these rebounds. So it could be a loss in the 2026 mapping cycle. We'll be releasing those numbers in spring of 27. We'll have a seagrass working group, and we look forward to sharing that data with you. I know the county and a lot of the field work has suggested there is a lot of haliduli down there, but again, it could be too sparse to actually be mapped in our 2026 seagrass maps. And if you would like to see any of our historical seagrass data, you can use that QR code up here. This is our seagrass mapping dashboard. You can actually compare 2 years of data. This goes back to 99. It doesn't go back all the way to 88. It does go back to 99. But you can select different bay segments up in the corner. You can compare 2 different cycles. You can switch it back and forth. It'll have the imagery. It'll have the seagrass maps. And when you zoom in, it'll actually show you how much seagrass acreage you're looking at and the change between those 2 years. So please use that. And we look forward to sharing what our 2026 seagrass maps have to show.
Thank you, Tara. Well, that was great. That really, took us through this transition from an open pass to water quality to habitats as we go along. So we're going to start working on getting ready for the discussion here and bring up our Mentimeter again. So, John, how do you think the pass, being open versus closed, will be impacting impacts to Little Sarasota Bay Watershed Management Plan projects?
Actually, most of the projects that are proposed are actually in the watershed itself, so I don't expect there to be much impact to those projects. And they're way up in the watershed. They're not in the bay, so I don't expect them to have any impact.
Is there funding for water quality projects in the Little Sarasota Bay Management Plan?
There are funding opportunities listed in the Watershed Management Plan. No, I don't know of any actual money that's been appropriated specifically to build any of those projects right now. They're all just recommendations that the county could move forward with if needed.
Okay. Will sediment, suspension, and nutrients stored therein near pass likely continue with higher flows?
I would suspect so, yeah. I mean, as long as the water's passing through the pass, it's going to continually stirring up the sediments and move things around. So I would assume so, yeah.
So for those of you who've been going to Midnight Pass over the years, before it opened, it was muddy. It was organic, rich material, which is really small and easily to suspend it. So it's just common sense would say if you put a high velocity water in a fine particle environment, those particles are going to be lifted up and moved around. I don't have any data for you, but you can see that in life. So it's very probable, I would say.
What techniques are involved in the highest category of nitrogen reductions of the Little Sarasota Bay Water Quality Project that John showed? Submitted by.
As far as I know, there's a couple of stormwater ponds being promoted, but the main thing is going to be inter-event treatment within the system. So even when it's not raining, we want to continue to clean up the water within the ponds and in the systems themselves. So we're trying to create continuous cleaning systems, I guess is the way to say it, for several places within the bay. But unfortunately, there wasn't a lot of open space in order to work with within Little Sarasota Bay. It's pretty, except for in uplands, up in the upstream areas, but downstream, there's hardly any place to do any real work.
Any continuous water quality stations or tide gauges in Little Sarasota Bay?
Not that I know of. There were a couple of creek elevation stations that contribute to the bay, but not within the bay itself that I know of.
Are native plants at Jim Neville recovering more quickly from salt spray than invasives?
The real salt impact was inundation. That was the big thing. And so, when we went out there after the 2 hurricanes, it's like the land had been washed. It was all sorted out. Logs had floated away, and a lot of stuff was just gone. I think the upside that we really like is a bunch of things didn't care about being underwater in the ocean for 2 days in a 2-week period. I mean, in a turbulent environment, and they look perfectly fine. Things like cedar, I thought that would be killed. It's not. So a bunch of things did fine. I don't know about spray, but it was a big, big effect. We think 1,000 trees were knocked down by the hurricanes. We can only guess.
If the southwest coast of Florida is nitrogen limited, what is the impact of biologically available phosphorus is trending up? So, yeah.
No. Well, I showed that total phosphorus is going up. I can't say it's dissolved because we're not measuring dissolved. We're measuring total orthophosphate is going down. So that's actually getting reduced. If it were to go up, it's if those ratios change. That's where we're going to start to see issues. And I haven't evaluated the ratios yet for this project. So that's something we need to look at. And that's where we could start to see some problems. It might be fine.
You mean a nitrogen limitation?
Mm-hmm.
Could you tell them what that means?
How about you?
No. Well, you're the one.
Watch that, Thomas. Yeah, so we are typically a nitrogen limited system here, meaning that we have plenty of phosphorus in our system and very little nitrogen. But when nitrogen does come in with stormwater or bursts from somewhere else, you can get these pulses of algae growing. You can either see it in small microplankton or macroalgae, which is what we've seen in times. And we really look at consistent ratio of N to P. Go back to your old chemistry books, Chemistry 101 or Water Quality 101, the Redfield ratios. We use that as a guideline as to when that ratio kind of gets out of this very well steady holding ratios, when you'll start to see organisms go crazy for it. I guess that's a simple way to put it, John, unless you want to add anything to that. Oh, I do want to add to the question, though, about the continuous nutrient sensors. That's been a big question in Sarasota Bay, Sarasota County for a long time. Can we do that, first of all? There are nutrient sensors that work in freshwater really well. There are a couple of nutrient sensors that kind of work in saltwater. Don't get sold on and I'm not going to name brands, but there are some that try to say that, yes, this is going to work with no problem. But there's a lot of problems with detection limits and how often you have to go out and clean up biofouling and stuff like that. We do currently have a nitrate system at New Pass that we're working on. It's a wet chemistry method. It takes a lot of effort to maintain it and make sure the chemicals that you're putting in it are working. I have a couple of Suna nitrate sensors that we've used offshore that can capture upwelling systems. In the bays and estuaries, they're finicky. It's really hard, especially if it's a high sediment area. So I think the technology isn't quite there yet, but I think there's a big push in the future to try to get these kinds of instruments in. So we are working towards that.
And as far as the TP trend, I'm not sure if it's really a trend. I mean, it's just 2 years that it's gone up a couple of times. But I wonder if that's more associated with just the amount of rain that we got over the last, to 2024. And we just washed out so much of the highly rich phosphorus soils in Sarasota County that I'm wondering if that's what's really could be driving those high annual geometric means. So it's just Sarasota County itself is underlain by high phosphorus soils. So it could be just that we got so much rain in those 3 years that we just washed so much more into the bay. But I mean, everything takes more monitoring. We get to see what happens.
Any thoughts on selecting Little Sarasota Bay stations in proximity to the pass for pre and post comparison?
Sure, I would love to. The monitoring program, though, is a very set monitoring program that, like I said, has been going on since 1998. We have those segments. The actual station within the segment changes each month. And it's based on, I mean, maybe back in your time when it was yeah, definitely I was a kid. I don't know. And so those are pretty well set, and that is for purposes of regulatory purposes, Clean Water Act, making sure we're meeting these numeric nutrient criteria. I would love to do more sampling and more work, but as we've mentioned, it takes funding and conversation to see, you know, how we can make that happen and look more into that. But I think it would be great to do that and more consistent monitoring of that.
Is there any change of the spatial distribution of water quality parameters within Sarasota Bay after the opening of Midnight Pass?
Yeah, and I didn't have time to go into all that. There are definitely some differences within the individual station. I mean, that would be at least a 15, maybe a 30-minute talk. But I did start looking at that to see if, like, that station 14.3 is where we did see most of the biggest, I don't know, impact, but I say that qualitatively, not quantitatively. And so that is something more that we need to look at in those details. You know, I didn't look at north and south of the opening. You know, we saw some of the physical change, you know, movement of water. So it would be really pertinent to tie that chemistry in with the physical movement of the water as well. And I have not done that yet. So to be continued.
Tara, how much damage from boat props on seagrass beds have you seen around Jim Neville?
So I haven't been out there recently. We've been out quite a few times, but right now it's the burial that we're concerned with and the trampling, because the seagrass meadows that were there are kind of buried. So any of that regrowth that's trying to come up is having a hard time with the recreation. So right now, to be determined with the boats, the scars themselves, but until that grass kind of recovers, then that's when you'll see more of that prop scarring. But right now, the burial and the trampling is a concern.
Why was Australian pine planted on Jim Neville Preserve?
I hate those people. No, I don't think it was planted. I hope it wasn't planted. You know, Australian pine's invasive, meaning it's like a weed that will grow in disturbed ground. And just like the other non-native plants, if you pour a bunch of sand out in this location, the first things that get a foothold are non-native invasive species. And so that's what happened. And it's been there for a long time. So it's been 60 years. It was enough to grow really big, complete tall forests. But I hope nobody planted them. They were popular for planting in the past, and people thought I kind of like them. They're okay. They're just a poor habitat plant that we can do much better.
Yeah, I think they used to sell those and pepper in nurseries. One of my neighbors has a hedge of pepper. He's very proud of when his parents planted that. John, got another one for you, Ryan. Since opening of the pass and more stakeholder use of the area, have you seen increased use of land on Jim Neville use and impacts?
There's a giant difference in the amount of kayakers that go to Midnight Pass. Midnight Pass is a really cool place to go kayaking. I highly recommend it. The water's beautiful. And so we do see, the Jim Neville Preserve is surrounded by a mangrove forest that's big and it's thick and it's really hard to walk through. It's easier for like teenagers, they'll do anything, but most people wouldn't wade through, all those mangrove roots and everything. So we have one entrance that's kind of hard to see if you don't know it's there. It's by channel marker 43 if you decide you want to go out there. And we just in the last few months have had people show up and say, hey, we're just going for a little walk. And we have 2.5 miles of trails that we've carved out. So there are places to walk around through the mostly invasive forest and then the restored area. So we're getting a few more people, but generally we thought people would show up right away, and it really didn't happen. We almost never see anyone out there except the people we bring.
Tara, what do you think will happen to seagrass distribution through Little Sarasota Bay over time?
Well, I think it's going to take some time to tell, but definitely with the advancements in wastewater treatment and the flushing from the pass being open could definitely increase our seagrass coverage. The largest seagrass the acreage that we had for Little Sarasota Bay was back in 2014, and it was over 900 acres. So now we're at about 600 acres, which is still over 100 acres more than back in 1988. So still room for expansion there, but I guess time will tell, and hopefully that flushing and all that'll help that.
would additional shoreline projects or living shorelines in Little Sarasota Bay be important to consider for addition to watershed management plans with paths now open?
I think additional shoreline projects would be beneficial whether or not the pass open. I mean, anytime we can try to restore some of the shoreline, we're actually being beneficial to the bay. So, yes, I think they would be still important to consider anywhere we can.
Is there any stratification observed in the water column within the bay in terms of water column?
Yes, and I did look at that a little bit before the meeting, but had to cut out slides. So yes, the answer is yes, especially in things like dissolved oxygen around that area. We do see time periods where it was below that 3 micrograms per liter and lower, especially in some of that mucky area. And with some of the other parameters too, it's going to take time to look at that data set. But yeah, it depends on the time of year. It depends on temperature and salinity. It depends on a lot of those things, but the answer, yes.
I was going to say, I think the estuary program, right after the storms, were out measuring dissolved oxygen right after the storms, and they saw like 2 months worth of low DO stratification within that whole area.
Yeah, especially with that freshwater runoff. And even when the pass opened, we were sampling in there, and you could see the salinity on the bottom. It was pretty close to Gulf salinity, and the top was just 15, 20 parts. Yeah. So. But it was mixing. Is anyone capturing use increases near pass and seagrass bed impacts?
From the imagery, you can tell how many boats, and we did some reflights, and you could definitely see the boats and how many people are down there. Obviously, it's gone viral for people recreating on it, but I'm not sure if anybody's actually monitoring. I know the Sarasota County has been doing a lot of seagrass monitoring down in that area, and I think that's to be continued.
Mm-hmm. I think it's definitely an area of Lee's focus. Yeah. Because it's not just that, it's all of our passes with a big bar inside. We see those impacts, heavy impacts. Should increased macroalgae monitoring speciation occur near the pass to capture nutrient uptake by macroalgae and changes in nutrient dynamics? Yes.
I'd say yeah. Ready? 1, 2, 3. Yes. Yes. I think the estuary program has started doing a lot more work looking at the macroalgae, and we do have seasonal macroalgae that comes in and out of the entire bay, sometimes more in pockets of areas. But yeah, absolutely, and probably impacting the seagrass too.
Yeah, absolutely. And there's the Eyes on Seagrass, the volunteer effort. So there's definitely a lot of eyes on this area. And again, the county and some of our field verification, our accuracy assessment. There's a lot of field work that goes into this. And, macroalgae is kind of normal in a system, just depends on the amount of it.
Yeah, and I think that's something Nicole and I have been talking about also, about expanding just our understanding of the speciation within what we're seeing. I mean, right now we're just kind of doing a total coverage, but really looking at that over time and finding what that natural background level would be. So we have a reference level over time to come back and compare to. I think it'll be important. Is post-storm nutrient data publicly available?
Yes, all of our data gets up. Oh, you want it? Oh yeah, all of our data goes to the county. It goes up. It's directly uploaded to WIN as well. Usually takes about a month once we've collected it to get it uploaded to the site. So it is publicly available. You can also reach out to Heather Bryan if you'd like some more information on the data. She's hiding back there. And then, of course, you can reach out to me as well.
I say it can also be found on the Water Atlas.
Oh yeah, and the Water Atlas.
Sarasota County sponsored Water Atlas.
You do not want for sources of information, that's for sure, which is great to have. Does that bring us to the end of the question? Yeah. Does anybody else have any questions from the audience you want to throw out there? Are we pretty good? Ready for lunch and break? Yes.
Water is definitely a lot clearer. I kayak out there all the time and have for years. And it's really, really different. And the velocities are really way higher. It's really a different place than it used to be. And it's nice. I like the open pass. Just as a kayaking experience, nice.
Well, thank you. Good. I guess we can move on and get on. All right. Well, again, a round of applause for our panel. Thank you. Thank you for taking the time.